The title of my research is Expectation Maximization Imputation in Forecasting the Rates of Unemployment in South Africa. This is the abstract, and the interested reader may pause and read on. The study compares last known value imputation and EM imputation to see how accurately the unemployment rate in South Africa will be predicted. Prior research has improved the accuracy of predicting the rates of unemployment in South Africa using machine learning methods over traditional statistical methods, deep learning, and feature selection. Previous work has used various imputation techniques such as forward imputation, constant imputation, mean value imputation, etc., with the last known value imputation producing the best result and has thus been used as the standard. EM imputation has not been employed for the missing data imputation. The feature set accessed from the South African Reserve Bank has values that are missing at random. EM imputation is applicable whenever the data is missing completely at random or missing at random. The aim of the study is to compare EM imputation and last known value imputation to better forecast the unemployment rate in South Africa. This study tests the alternate hypothesis, expectation maximization imputation produces better performing models compared to the last known value imputation, and the null hypothesis, expectation maximization imputation does not produce better performing models compared to the last known value imputation. The data utilized was sourced from the South African Reserve Bank and the Bureau for Economic Research. It had 147 features ranging across the South African economy and the target variable being unemployment rates of South Africa. The data had missing values due to mixed frequencies. Therefore, the data was upsampled to a quarterly frequency, and then the missing values were imputed using last known value imputation and EM imputation. Three traditional statistical models, Holt-Winters, autoregressive integrated moving average, simple exponential smoothing were selected since they are one of the best traditional statistical models in predicting the South African unemployment rate. Three machine learning methods, long short-term memory networks, gated recurrence units, and the multilayer perceptron were selected because they are some of the best performing machine learning methods in predicting the South African unemployment rate, with the LSTM being shown to be the best. The performance measures used are the standard deviation over errors, root mean square errors, mean absolute error. The EM imputed data was able to capture the trend, seasonality, and residuals of South African unemployment rates just as well as the last known value imputed data. As we can see from the figures below, the South African unemployment rates trend fluctuates upwards, and we can see from the seasonality and the residuals that they are quite similar for both data sets. Traditional statistical models performed better when the expectation maximization imputed data was used. The machine learning methods performed better when the last known value dataset was used. The LSTM and the GRU had the best performance overall, and this is expected as prior research has shown that LSTM is the best forecasting model for the unemployment rate in South Africa, followed closely by GRU. The last known value imputed data had the lowest standard deviation over errors for both deep learning and traditional statistical models. The hypothesis H1, expectation maximization imputation produces better performing models compared to the last known value imputation, was tested by predicting the South African unemployment rates using macroeconomic variables from the South African Reserve Bank dataset. In 8 of the 36 of the evaluations, that is approximately 17%, the EM imputed data set trained models had lower error rates. Therefore, we fail to reject the null hypothesis. Expectation maximization imputation does not produce better performing models compared to the last known value imputation. 83% of the models had lower error rates when the last known value dataset was used. This study has contributed to the existing body of work done in the forecast of the South African unemployment rates by showing that there is a place for expectation maximization imputation in the forecast of the South African unemployment rate when traditional statistical methods are being considered or used.